In early 2025, something subtle yet staggering occurred in the heart of a quiet physics lab. A single tick from an atomic clock fell out of sync, by just 1 quadrillionth of a second. A discrepancy so minuscule it defies imagination, yet large enough to challenge the laws of reality. In a world where equations stretch to 18 decimal places, even a flicker that small as a thunderclap. It sent shockwaves through the scientific community, igniting whispers of a deeper mystery. Because in the realm of ultra-precise physics, nothing deviates without reason. And time, once thought to be an unwavering river, was suddenly questioned at its source. Today's atomic clocks are more than instruments, they are revelations in steel and laser light. These marvels are so sensitive, they can detect the warping of time caused by gravity just 1 millimeter apart. Imagine placing 2 clocks on a tabletop, one slightly higher than the other. The lower one ticks more slowly. Time, quite literally, bends under the weight of gravity, even across the width of a credit card. This isn't science fiction. It's real, measured, and undeniable. At GILA, a joint institute of quantum precision, researchers crafted the world's most advanced optical clocks. Built with strontium atoms, held in lattices of laser light, they form timekeeping machines of almost alien accuracy. 2 clocks, alike in every way. Except for one difference, their height. Separated by just 1 millimeter, they ticked out of phase. A silent confirmation of Einstein's theory, made visible in the lab. Time slows closer to the Earth. Even your head ages faster than your feet. The relativity of time is not a theory, it's a measurement now. But what if we go smaller? What happens when we descend beneath the surface of atoms, to the tangled roots of the quantum realm? Here, the gravitational pull of Earth fades into quantum uncertainty. Yet even in this chaos, the clocks whisper something unexpected. Time, it seems, is not a universal rhythm, but a shifting, local condition. As personal as breath. As fragile as a thought. This changes everything. From GPS satellites in orbit, which drift without precise relativistic correction, to the world's financial systems, where billions hinge on femtosecond trading speeds, to the emerging architecture of quantum computers, where time is the heartbeat of information. Timekeeping has become reality keeping. And the instruments we use now gaze into time's substructure with impossible clarity. Then came the next leap, a timepiece unlike anything before it. Built at the Physikalische Technische Bundesanstalt in Germany, this clock uses ions of indium and ytterbium, suspended in a Coulomb crystal. Its precision is so staggering that had it been running since the birth of the universe, it would be off by less than 1 second today. Let that sink in. From the Big Bang until now, less than a second of error. That's not evolution. That's a redefinition. For the first time since the 1960s, humanity is rewriting its definition of the second. No longer based on microwave transitions in cesium atoms, but now on optical frequencies, thousands of times more stable and refined. A 1,000-fold increase in temporal resolution. We are no longer counting time. We are dissecting it. But deeper still lies a question that haunts the edge of physics. What if the constants of nature, the sacred values we hold as unchanging, aren't constant? What if the speed of light trembles at the farthest edges of space? What if the charge of the electron dances, imperceptibly, to a hidden rhythm? With today's clocks, these whispers can finally be heard. And still, the clocks tick on. Each pulse a beacon in the void. Each measurement a step deeper into the unknown. If these machines are right, and they appear to be devastatingly right, then time is not a straight line. It is a terrain. And we are only beginning to chart its contours. If the nuclear clock becomes widespread, we may witness the rise of planetary networks synchronized to within a billionth of a second. New interplanetary navigation systems. Quantum communication grids. Entire digital civilizations built on time too fine for human senses. This is not the future. It's happening now. Time has become the most precious, most unstable, most revealing quantity in science. And the more clearly we look at it. The clocks kept ticking. But now, they weren't just marking time, they were measuring the shape of reality itself. In hidden vaults beneath mountains and in orbiting satellites above the Earth, a new kind of experiment had begun. One not aimed at particles or forces, but at time's most delicate fractures. Across the globe, researchers began to synchronize atomic clocks with unprecedented precision. Each one a sentinel, watching not just the flow of time, but the tremble of something deeper. Something ancient. Something possibly alive. And then it happened. For just a few hours, clocks spread across thousands of kilometers fell into discord. The discrepancy was infinitesimal, less than a billionth of a second. But the pattern was identical. Each clock slowed, subtly, in exact synchrony. As if time itself had sighed. It wasn't equipment failure. It wasn't a solar flare. It wasn't explainable by any known force. The only possibility left on the table was a signal. A ripple. A wave passing through spacetime itself. Theorists rushed in, clutching models long deemed fringe. Some spoke of scalar fields interacting with dark matter. Others proposed relics of inflation, ghosts from the birth of the cosmos brushing against our detectors. A few, whispering behind closed doors, dared to suggest something stranger still, a message. Could time be modulated? Could a force, natural or not, encode information not in particles, but in the rhythm of seconds? Just like radio waves carry voices. Could the universe be whispering, not through matter, but through time? To test the idea, the most sensitive nuclear clock on Earth was moved deep underground, into a magnetically shielded vault cooled to near absolute zero. It ticked, alone, untouched by the world. And then, at 3:14 Coordinated Universal Time, it glitched. Just once. A flicker. The kind of anomaly that, in the past, would have been discarded as noise. But this time, it matched the spaceborne clocks too. Thousands of kilometers away. The exact same moment. This couldn't be ignored anymore. Time was doing something it had never done before, not just flowing, but reacting. Not just bending under gravity, but responding. And the implications were staggering. Suddenly, theories from the edge of physics re-entered the conversation. What if time itself was not a background, but a fabric woven by a deeper, informational field? A holographic projection. A simulation. Or even a conscious matrix, correcting itself moment by moment? Quantum physicists, cosmologists, even computer scientists began to meet in secret conferences. Not to debate if this was real. But why? And what to do next? A proposal emerged. Synchronize hundreds of ultra-precise optical and nuclear clocks in a global array. Stretching from Earth's surface to satellites in orbit and eventually to the Moon. Not just to watch for deviations, but to listen. To treat time itself as a channel. A bandwidth. A cosmic code. This was no longer just metrology.